Greetings everyone, we are the Group 4 and our topic is Wind Power Stations. Here are our members, Aldrin Clive Momo, Don King Mayol, Harold Vincent Reyes, Desmer Jude Pahe, John Justin Medrano, Muhammad Ali Shakil Murtda, Romel Leo Onke, Sean Christoph Ongoy, and Sean Medina. So, in this era of technology, electricity has become a necessity for societies and industries to properly function as a collective whole. Due to this, the demand for electricity has drastically increased and non-renewable resources that are used as fuel are being consumed at an alarming rate. To mitigate these issues, experts have developed various structures where each type of structure uses a specific renewable resource to effectively and efficiently produce electricity to meet the demands of the people without losing non-renewable resources. One such structure is the wind power station. So what are wind power stations? A wind power station or wind farm, also called a wind park or wind power plant, is a group of wind turbines in the same location used to produce electricity. Wind farms are in vary in size from a small number of turbines to several hundred wind turbines covering an extensive area. So what are wind turbines, you ask? In simple terms, it is a device that converts wind's kinetic energy into electrical energy. Wind turbines are manufactured in a wide range of sizes with either horizontal or vertical axes. They are an increasingly important source of intermittent renewable energy and are used in many countries to lower energy costs and reduce reliance on fossil fuels or other types of non-renewable resources.
So, how does a wind turbine works? Wind turbines work on a simple principle. Instead of the electricity using to make a wind, the wind turbines are used in order to make electricity. So, the wind turbine works when the wind turns the propeller like blades of a turbine around the rotor, which is connected to a generator, then creates electricity. So, wind turbines work as turning blades or fans in order to create electricity. So when wind blows across the blade, the air pressure on one side of the blade decreases, which is made the difference in pressure across the two sides of the blade, creating both lift and drag. So the force of the lift is stronger than the drag, which causes the rotor to spin, which is connected to a generator that that is connected through a shaft, then generates electricity, which allows for a physically smaller generator. This translation of aerodynamic force to rotation of a generator creates electricity. So the different parts of turbines will be going to discuss in the next slides.
So, the parts and functions of a wind turbine. So, the main parts of a wind turbine is number one, generator. A generator is a device that converts motive power into electrical power for use in an external circuit. Sources of mechanical energy include steam turbines, gas turbines, water turbines, internal combustion engines, wind turbines, and even hand cranks. So the type of generator most used in wind turbines are the permanent magnet synchronous generators. Permanent magnet generator offers a constant excitation produced by permanent magnets. It is very useful in the process of generating electricity when the rotor is being rotated. The voltage will be generated directly in the stator winding. Next is the rotor. The rotor connects to the generator either directly or through a shaft and series of gears that speed up the rotation and allow for a physically smaller generator. This translation of aerodynamic force to the rotation of a generator creates electricity. So how does a rotor work in a wind turbine? So the turbine catches the wind energy with their propeller-like blades, which act much like an airplane wing. When the wind blows, a pocket of low-pressure air forms on one side of the blade. Then the low-pressure air pocket then pulls the blade toward it, causing the rotor to turn. Next is the tower. Wind turbine towers are the tower of the wind turbine carries the nacelle and the rotor. Towers for large wind turbines may be either tubular steel towers, lattice towers, or concrete towers. Guide towers are only used for small wind turbines. So there are two types of towers for wind turbines. First is the self-supporting or freestanding tower and the guide tower supported with wires. Next is the base. So the base is a large and heavy structured block of concrete that most hold the whole turbine and the force that affect it. So the base is made up of steel and the foundation is generally simply concrete blocks called footings that are placed under building walls and columns or in the case of wind turbines beneath the tower. Next is the hub. The hub of a wind turbine is the component that connects the blades to the main shaft and ultimately to the rest of the drivetrain. The hub transmits and most withstand all the load generated by the blades. Hubs are generally made of steel, either welded or cast. What is the hub of a wind turbine made of? So, a German company has designed and developed an innovative hub for wind turbines made entirely from composite structures and is approximately 50% lighter than comparative steel components. Next is the nacelle. The nacelle of the wind turbine houses the drivetrain and other top components. It sits on the top of a yaw bearing that allows it to rotate as the wind direction changes. The nacelle must be accessible for maintenance and repair work. Access is usually via lift and ladders within the tower. So what are wind turbine nacelles made of? So it is made up of cast steel. The front or main frame of the nacelle is generally made of cast steel and hold the yaw system, gearbox, and main shaft. Next is the transformer. Transformers act as a link between wind turbines and distribution grid. It steps up the low output voltage from the generator to a higher distribution voltage level. However, wind turbine transformers are considered to be one of the most sensitive and weakest component in a wind farm. So where is a transformer in a wind turbine? At wind farms, this translates to placing the wind generator and its associated transformer close together. So for land-based sites, the turbine set up transformer can either be located near the tower base or within the tower nacelle. So
Advantages and disadvantages of wind power system. At this point, the future of wind energy seems promising. This may be the case, but it is important to be aware of both the pros and cons of this system. The advantages of wind energy are more apparent than the disadvantages. The main advantages include an unlimited, free renewable sources, which is the wind itself, economic value, maintenance costs, and placement of wind harvesting facilities. On the cons side, wind turbines can be noisy and unappealing aesthetically, and can sometimes adversely impact the physical environment around them. Similar to solar power, wind power is also intermittent, meaning the turbines are reliant on weather and therefore aren't capable of generating electricity 24/7. So one of the advantages of wind power system is it is renewable, inexhaustible, and clean. Unlike coal, natural gas, or oil, generating electricity from wind doesn't result in greenhouse gases emissions. Next is low operating costs. As far as upfront costs go, wind farms or individual turbines can be expensive to install. However, once up and running, operating costs are relatively low. Their fuel, which is wind, is free, and the turbines don't require too much maintenance over the course of their lifetime. Next is efficient use of land space. Wind farms can take up a lot of land space. However, the actual turbines and equipment do use a lot of real estate. This means that land used for wind turbines can often also be used for other purposes, such as farming.
And here are the disadvantages. So, intermittent. Wind power is considered highly intermittent because it is a variable power source. This means that it is reliant on a number of variables such as wind speed and air density. In short, In short, wind turbines' effectiveness in generating electricity depends on the weather. So, noise and visual pollution. When the rotors rotate, it produces a wind vortex which then creates noise pollution to its surrounding. Mechanical operation of wind turbines also contribute to the noise due to the required size of the wind turbines to properly capture wind. It can interrupt or be a hindrance to otherwise scenic landscape such as mountain ranges, lakes, and oceans. So remoteness of location, you cannot just put wind turbines anywhere. It needs to be placed in an area that gets sufficient air and has a good weather for the turbines to work effectively and efficiently.
In the Philippines, we have 10 wind power plants in total. Six of them are operational, which are the Burgos Wind Farm, the Bangi Wind Farm, and the Caparispisan Wind Farm, all located in Ilocos Norte. San Lorenzo Wind Farm in San Lorenzo, Guimaras, Pililla Wind Farm in Pililla, Rizal, and the Nabas Aklan. The Mindoro Wind Farm in Puerto Galera, Oriental Mindoro, the Balawi and Kaunayan Wind Farm in Pagudpud, Ilocos Norte, and the Sembrano Wind Farm in Pililla, Rizal are now are all now under development and is being proposed in Sibuna Guimaras, which is the Sibuna Wind Farm.
Out of those 10 wind projects, the 150 megawatts Burgos wind farm is the biggest wind farm in the Philippines and also became the Southeast Asia largest wind farm. The project is located approximately 500 kilometers north of Manila and spread across 600 hectares, covering the barangay of Sawit, Nagsarot, and Poblacion within the municipality of Burgos in Ilocos Norte Province. The onshore wind farm was commissioned in November 2014 and is owned and operated by the EDC Burgos Wind Power Corporation and was the first wind project nominated for the Philippine government Feed-in Tariff Incentive Scheme. Burgos Wind Farm consists of 50 Vestas V90 wind turbines with a rated capacity of 3 megawatts each and can generate approximately 370 gigawatt-hours of electricity a year, which is used to power more than 2 million households. The Burgos Wind Farm project was awarded the 2015 Asia Power Engineering International Best Renewable Energy Project for achieving 5 million safe man-hours without incident.
So, what do mechanical engineers do in wind power stations? Generally, mechanical engineers design, develop, and test machines involved in operating turbines and wind farms. They also work on the machinery and manufacturing processes used to make them. Mechanical engineers who may deal with manufacturing spend much of their time in factories. Some split their time between a home office and installation sites. Frequent travel is common. This may include international travel, since many major turbine manufacturers are located in other countries. Specifically, mechanical engineers work on wind turbine siting, components and systems, contributing to performance optimization and cost reductions for project developers, manufacturing, and operation companies.
So this is the end of our topic, and I hope you enjoyed our lesson. And thank you very much. This is Group 4 signing off.